So you have four output. So two rows, two column will be perfect. 2 into 2 is 4. First index position पे क्या है? Your dist plot of age. So let us write down dist plot of age. And in this thing itself, let us add color is equal to red. R is for red. And इसको ही title set करते हैं. Second इसको title as age histogram. Right? Now we have second index. This plot of what do you want? BMI. So this plot of BMI and color let us add as red. R for red. We are setting title as BMI histogram. Third is third index position. Charges in INR ही चाहिए क्या third पे? This plot of charges in INR, right? And इसको अगर color आपको add करना है. Fourth is count plot ना. So figure dot add subplot SNS dot count plot of sex column. Gender is equal to sex only because in sex column itself we have gender, right? So if you see this is red, right? Agar if I want to change this color to black, I'll write down black over there. So color black. Third is ka color by default ये है. Suppose you want another color, charges ना है ना रखो. So let us see the difference. How you can add the color. Comma color is equal to green color you want. So it is changing into green. And you want to set a title for this. So dot set underscore title charges in INR histogram. Right? So likewise you can set the color and everything. यहाँ पे भी अगर आपको चाहिए color is equal to brown, you'll write down this and the color will be brown. Orange. So likewise you can do it. It's very easy. So this is what we have for this. Now we'll see. If you remember yesterday we have discussed the box plot concept, right? Do you remember box plot? How we generally plot the box plot is SNS dot box plot df of age column. Everybody remembers this, or is it? Do you remember this box plot? This is our box plot, right? This is lower whisker region. This is upper whisker region. ये Q1 है, ये Q3 है, IQR है, right? So we will understand how to detect the outliers in our data in this session. So in this thing, we will make use of different methods. What are the different methods that we have to detect the outlier? First is box plot or whisker plot. इसी को बोलते हैं whisker plot. Second method is scatter plot. Third method that we have is Z score or empirical rule, which is nothing but data points beyond plus or minus 3 standard deviation. Plus or minus 3 standard deviation are considered as outliers. And fourth method that you have is IQR, which we have seen yesterday, or box plot, right? अगर ये रीजन के पहले और ये रीजन के बाद में अगर डेटा है तो we have outliers in our data. Now in age column we don't have outliers. Similarly, if you go for charges in INR column, do we have outliers? We have outliers over here, right? Is it clear? So we have this four methods. In this four methods, method 3 and 4 are the statistical method. ये जो method 3 and 4 है, that is statistical method. मतलब we use our statistical method, stats method. What do? We use statistical concepts to find out the outliers. But this 2 and 1 is box plot is nothing but the visualization tool, and scatter plot is also visualization tool, right? And what is this Z score? Z score or empirical rule? Just like if you remember, we already have discussed this point in our outlier session. So this is your distribution. This is your distribution, right? And in this thing, the data points, what we do is, suppose we want to make use of, we are interested to do the analysis of, we are interested to go with the wealth analysis of the of our organization. Let's say you are working in TCS and you are interested to do create the wealth analysis of the organization or wealth analysis of your organization for the employees. Now we have plotted this distribution like this, and we divide our data into three parts. ये हो गया first part, ये हो गया second part, and this is your third part. So what is this length? This is one standard deviation. ये हो गया two standard deviation, and this is your three standard deviation, and this is mean value. So as you're going to the left, this will be minus one standard deviation. This will be minus two standard deviation, and this will be minus three standard deviation, right? Now ये जो one standard deviation है, it comprises of only 95% of the data. Let us go with this three standard deviations. If I take this, see. This is 68% of the data, right? Was one standard deviation. तो मीन के पहले और मीन के बाद में इफ यू टेक वन स्टैंडर्ड डेविएशन तो यहाँ पे कितना डेटा will be there? It will be 68%. If you consider two standard deviation now, this two standard deviation range, it will cover 95% of your data. And if you consider three standard deviation, three standard deviation zone, So in this region, it will be 99.7% of the data, right? So one standard deviation is 68% data, two standard deviation is 95% of the data, three standard deviation is 99.7% of your data. So let us take this figure and let us paste it over here. 68, 95, 99.7, right? Now is it clear for everyone? This is a plus or minus three standard deviation. So if you take any data and if you plot distribution, अगर आप standard deviation calculate कर रहे हो, तो it will take the this much data and plus or minus three standard deviation के beyond अगर कोई data रहेगा, तो we consider that as the outliers, right? And what is variance? It's just average squared distance of each data point with respect to mean. And what is this thing? Standard deviation. What is standard deviation? It is square root of variance. Standard deviation क्या है? Square root of variance. अब इसका physical significance, how you can understand is, let us take the distribution. Suppose this is your distribution, and let us add few data over here. 1, 2, 3, 4, 5, 6, 7, 8. So इसका distance, अब ये लेफ्ट साइड में, तो ये निगेटिव रहेगा, राइट? एज वी नो इन नंबर लाइन, लेफ्ट में क्या रहता है? दिस इज -1, -2, और ये प्लस जोन है, तो दिस इज नेगेटिव डिस्टेंस, नेगेटिव नेगेटिव नेगेटिव. सपोज दिस इज -2, दिस इज -3, this is -4, and this is -6. This is 2, this is 3, this is +4, and this is 6, right? Now if you just consider this thing, and if you find the distance, why we are taking squared distance of each data point with respect to mean variance? अगर आप distance calculate करोगे, इसका sum करोगे, -2, -3, -4, -6, and what do we have? We have 2, 3, 4, and 6. Now if you just take the sum of this distance without taking square of the distance, it will be 0, right? So ये distance 0 है क्या सब data point का? Is distance 0? Distance is not 0. Only thing is negative and positive is cancelling each other. Now if you take square of the, if you take square of this every term, 2 raised to, or let's take is equal to this raised to 2. If you take square and if you just drag this down, and then if you calculate this sum now, तो ये हो गया average square distance of each data point. अब इसका average निकालना है ना. So how many data points are there? We have 1, 2. How many data points are there? We have 8 data points. So we'll just divide this by 8 to calculate the average, right? Or simply if you calculate average, then also you'll get average function kiska iska. It will be 16.25. So this is your variance. तो वेरिएंस अगर आपको कैलकुलेट करना है, तो इट इज एवरेज स्क्वायर डिस्टेंस ऑफ ईच डेटा पॉइंट विद रिस्पेक्ट टू मीन. And what is the standard deviation? It is just like square root. So we'll take SQRT, square root of this thing. Now why we generally take square root is 16.25 is the variance. What does it means? कि it is average square distance of each data point with respect to mean. तो अगर मैं यही यूनिट यूज कर रहा हूँ 16.25, and if I just have to plot this thing again to specify what is variance, तो वेरिएंस 16.25 है, मतलब इट इज टू हाई, राइट? आपके डिस्टेंस कितना है सब डेटा पॉइंट का? -2, 3, 4, 6। एज कम्पेयर टू दैट 16 इज वेरी हाई। तो वो सेम यूनिट में लाने के लिए, सेम यूनिट एज ऑफ डेटा, वी टेक द स्क्वायर रूट। तो 16.25 का स्क्वायर रूट क्या रहेगा? इट विल बी 4.03। नाउ इट विल बी इन द सेम यूनिट ऑफ योर data points. So this is variance and standard deviation that we have to discuss in the statistics. So what we'll do now is we'll plot the box plot for BMI. So we'll just take this out, Control C, Control V, and we'll just do it for BMI column over here. And you can see that we have outliers in this data. Yes or no? So BMI के लिए outlier है, charges है ना, INR के लिए outlier है, but outlier is not there for each column. Now how to detect this outlier? Outlier कैसे detect कर सकते हो आप? So for this thing, we'll write down the detecting the outlier as part of your heading. So let us write down this detecting the outliers, and let us write down this thing. So before this, what we'll do is we'll create a subplot to understand the subplots for these three columns, और लेफ्ट साइड में रहेगा आपका हिस्टोग्राम फॉर ईच कॉलम, और राइट साइड में रहेगा आउटपुट के बॉक्स प्लॉट. सो वी आर कंपेयरिंग हिस्टोग्राम विद बॉक्स प्लॉट. तो जस्ट लाइक लेफ्ट में ये जो आउटपुट है ऐसा सब प्लॉट्स का, तो लेफ्ट में हिस्टोग्राम रहेगा और राइट में बॉक्स प्लॉट रहेगा. लेफ्ट में हिस्टोग्राम रहेगा वही कॉलम का, राइट में you will have the box plot. So let us create these subplots. Now we will write down fig is equal to plt dot figure. Fig size is equal to 25, 40. Ax is equal to fig dot add underscore subplot 3, 2, 1. Sns dot disk plot of df of h column. Then ax is equal to fig dot add underscore subplot 3, 2, 2. SNS dot disk plot df of h. Again, ax is equal to fig dot add underscore subplot 3, 2, 3. SNS dot disk plot नहीं, 2 के लिए you should have box plot, right? Because right में box plot चाहिए. This plot of, let us go for BMI column, df of BMI, and let us do this. Control C, paste over here. Box plot की जगह BMI के age की जगह पे BMI रहेगा, and this thing is remaining index number. So we'll paste it over here. This will be 4, and we can copy this thing to add 5th index and 6th index. This is your 5 and this is your 6. So BMI की जगह पे now it will be charges in INR. Here also it will be charges in INR. If you run this, you are going to get this thing. So this is how we can create this. Now you can compare the histogram with the outliers, right? If you see this distribution, ये right hand side में ज़्यादा data है, right? So it will be outliers most probably. Now we'll detect the outliers. How to detect the outliers? Let's say we are interested to detect the outliers for BMI column. For BMI column, do we have outliers? Yes, we have few outliers. तो ये जो outliers है वो उसके data points कौन से है? We want to see that. So we'll define Q1 is equal to df of call, sorry df column. उसमें quantile function use करेंगे because it is 25% Q1. Q3 is it's always 75%, so 0.75. IQR is Q3 minus Q1, and will display df dot loc df of call less than Q1 minus 1.5 times of IQR, or let us add this condition, df of call greater than Q3 plus 1.5 times of IQR. 1, 2, 3, 4. df of call less than Q1 minus or df of call greater than Q3 plus 1.5 QR. Mm. If we run this, it will be having the error. What is this error? This should be closed over here, and it will be correct. So ये जो BMI के लिए डेटा है, ये डेटा पॉइंट्स 1 2 3 4 5 6 7 8 9 9 है ना, 1 2 3 4 5 6, हाँ we have 9. तो ये BMI के लिए अगर डेटा है तो ये डेटा है आउटलायर्स, मतलब ये जो डेटा है उसका वैल्यू वी हैव फाइंड आउट ओवर हियर. Now if you go to the if you use the formula, let's say we'll find the IQR. IQR क्या है? Q3 minus Q1, right? So let us find the formula and let us check ये, let us confirm ये outliers है कि नहीं. तो Q3 है 34.69, Q1 है 26.29. तो IQR will be Q3 minus Q1, so 34.69 3750 minus Q1. Q1 क्या है? 26.2962. And if you just print what is the ये IQR है, we'll find upper whisker region. उसका फॉर्मूला क्या है? Q3 plus 1.5 times of IQR, right? Upper whisker region का फॉर्मूला क्या था? This is your box plot. This is your upper whisker region. This is your lower whisker region. This is your Q3. So it is Q3 plus 1.5 times of IQR, right? ये हो गया upper whisker region. This is Q1. So Q1 minus 1.5 times of IQR. This will be your lower whisker region. We'll find this thing now. Q3 plus 1.5 times of IQR. So it will be 34.69 this thing. ये Q3 है plus 1.5 times of IQR क्या है? This is your IQR, right? We'll take this, paste it out here. ये हो गया 47.29 हो गया अपर whisker region. Similarly lower whisker region का फॉर्मूला क्या है? Q1 minus 1.5 times of IQR. Is it correct? Q1 minus 1.5 times of IQR. Now, what is your Q1? It is 26.296250. This is your Q1 minus 1.5 times of IQR. What is your IQR? This value is your IQR. You paste it over here, and this is your lower whisker region, right? Now देखो जो सारे डेटा पॉइंट्स है यहाँ पे 47.29, 13.69, ये जो सारे डेटा पॉइंट्स है इधर 47 से ज्यादा रहेंगे बिकॉज ये हो गया 47. अभी वी हैव फाइंड आउट इट इज कैलकुलेटेड राइट. ये हो गया 47.29, ये हो गया अपर विस्कर रीजन एंड ये हो गया लोअर विस्कर रीजन. तो इसका वैल्यू क्या है 13.69, 13.69, राइट. तो विल कैलकुलेट दिस नाउ. मतलब विल सी कि 47.29 से ज्यादा है या बिकॉज आउटलायर के लिए क्या कंडीशन है 47.29 से ज्यादा चाहिए ग्रेटर देन और आइदर दिस थिंग और लोअर इसका रीजन से कम चाहिए. तो 13.69 से कम या फिर 47.29 से ज्यादा. सी दिस ये आउटलायर है ना 47.29 से ज्यादा है सब. सर नो. So it is we have ensured that these are our outliers. So similarly if you do this for your second column which is charges in INR. Charges in INR. So these are the outliers that you have. Right? And why we are not getting this? Okay. Display this thing. Now this is remaining. ELT dot figure. We have to set figure. उसमें fix size देना है. Fix size is equal to 10,6. SNS dot box plot df of column. If you run this, आपको ये प्लॉट भी आएगा यहाँ पे. So I'll just do it for this thing as well. तो ये आउटलायर से और आउटलायर से आपके ये वैल्यूज. Is it clear for everyone now? This is what we have, and you'll ask this question ki why we have considered the display. So I think we have discussed this, but let's go with the display versus print. Now you'll get this at this point of time itself. If you write print df, see this is your print, right? Output देखो print का और display का output देखो display df, display df. Can you see this output, this and this? It's very मतलब print का output is not aesthetically good and display का output is aesthetically good, right? So we will just take this image. ये है print का output and ये है display का output. Sorry, ये है display का output and ये है print का output. So print is this, display is this, right? So this is your difference. And if you just want to read this, you can read this article. Print is primarily used for debugging and displaying the simple text output. The output of print is often unformatted and lacks visual appeal. On the other hand, display function is typically used in data analysis and visualization to display data in more organized and aesthetically pleasing format. It is often used in Jupyter notebooks and other interactive environment to show data frames, plots, charts, and other types of graphical representations. The display function can also be used to format, stylize the output of a data frame or other data structure. So this is what we have. I'll just paste it over here and you can have this. So ये हो गया difference between print and display. Now we'll see, ये तो अभी outlier हो गए, but how to remove this outlier? Outlier treatment. How to remove this outlier? We'll see this after the break. And this logic we have not discussed. What is this logic? It's just like, what we have done is, I'll just explain these lines of code. देखो लाइन नंबर 1 में तो अपन कॉलम स्पेसिफाई कर रहे, Q1 Q3 डिफाइन कर रहे, IQR का फॉर्मूला डिफाइन कर रहे. लाइन नंबर 5 में व्हाट वी आर डूइंग इज, so this is your Q1 value, this is your Q3 value. Sorry, just a minute. Not Q1 Q3, upper whisker and lower whisker. This is your lower whisker region, this is your upper whisker region. ये हो गया Q3 and ये हो गया Q1, right? Now what we are doing in line number 5, we are displaying that particular data point. LOC क्या करता है, रो फेच करता है ना LOC, we have seen this. DF of column किसके लिए, चार्जेस इन, कौन सा कॉलम था ये, चार्जेस इन INR, राइट? तो चार्जेस इन INR कॉलम के लिए लेस देन Q1 minus 1.5 times of IQR. Q1 minus 1.5 times of IQR कहाँ पे रहेगा, यहाँ पे. तो अगर ये रीजन में you have data point, it will take this. We are using OR condition, this is OR, जो vertical line है that is your OR condition. और अगर DF of column greater than Q3 plus 1.5 times of IQR रहेगा, मतलब in this region, अगर data point यहाँ पे रहेगा, so we'll fetch this thing by using DF of LOC. And you know OR condition क्या करता है, अगर ये true रहेगा, ये false रहेगा तो भी output देगा, ये true रहेगा, ये false रहेगा तो भी output देगा. And condition के लिए दोनों true चाहिए रहते, right? And just we are printing this thing, so we are getting the outliers over there. So this is the logic that we are using over there. Now we'll take a break for 10 minutes. It's 11:58. Let's have a break. We'll meet exactly somewhere around 12, 8. Yeah. You can practice this and let me know if you are having any error or not. And before that, you can let me know in the you can, if you have any questions, you can let me know in the chat. Now let us see how to treat this outlier. So in order to treat the outliers, we'll create the function. If you remember how we used to create function, we used to write down def to define the function, right? तो ये फंक्शन का नाम दे रहे replace underscore outlier my df comma column mean is equal to my df of call dot mean open and close bracket. Q1 is my df of call dot quantile 0.25. Q2 is my df column dot quantile 0.5. Q3 is my df of call dot quantile 0.7, right? And we'll find the standard deviation is equal to my df of column dot quantile 0.7. Sorry, standard deviation will be std, right? So this is done. Now we are interested to find the IQR, and obviously IQR will be Q3 minus Q1. Then we'll find the lower whisker region, or let us write down lower limit for this. Same formula. We have Q1 minus 1.5 times of IQR, upper limit is equal to Q3 plus 1.5 times of IQR. And we have different methods. So method 1 for replacing outliers using IQR. What is method 1? So method 1 we generally don't use, but I just want to tell you कि ये method 1 है. That is the reason we are just using hash over there. Comment पे लिख रहे my def of LOC of my def of call. अगर तुम्हारा less than lower limit जो है which we have defined, lower limit, अगर कॉलम लेस देन लोअर लिमिट है तो वो कॉलम किससे रिप्लेस करेंगे, Q1 से रिप्लेस करेंगे, राइट? एंड इफ माई df डॉट loc of my df of call is greater than upper limit, we will replace that column with Q3. And sorry, this is your method 1. So ये Q2 से रिप्लेस करते हैं, मतलब median से. We are replacing outlier with median. तो यहाँ पे median लिख रहा हूँ मैं, but we generally don't use this. इसमें क्या हो रहा है कि if we have outliers, we are replacing that with median. And median कहाँ पे रहता है तुम्हारा box plot में? It will be over here, right? So ये हो गया median Q2. So ये अगर outliers है यहाँ पे, so we are going to replace this outlier with this value, median value. Similarly, we have another method which we will use in this function, method 2, for replacing outliers using IQR. So my df dot loc of my df of call, if it is less than lower limit, we are going to replace this column with Q1, and my df of loc of my df of call, if it is greater than lower, no? If it is greater than upper limit, we are going to replace this column with Q3. So how this is Q1 and this is Q3. So instead of replacing with q2, we are replacing this with q1 value, or we are replacing this with q3 value. And then यही आपका फंक्शन है. Then we'll return the df. और यहाँ पे क्या लिखा है? my df लिखा है ना, so we'll return my df. Now this is done. Now we are interested to use this function. But ये फंक्शन अगर आपको वर्क हो रहा है कि नहीं ये देखना है, तो अगर उसमें एक फंक्शन बनाना होगा. लेफ्ट साइड में बॉक्स प्लॉट विदाउट और विथ आउटलायर्स रहेगा, और राइट साइड में क्या रहेगा? बॉक्स प्लॉट विथ विदाउट आउटलायर्स. लेफ्ट साइड में बॉक्स प्लॉट विथ आउटलायर्स, राइट साइड में बॉक्स प्लॉट विदाउट आउटलायर्स. So let us do this. Let us define odt underscore plots. इसमें mydf comma column पास करेंगे, f comma. Now this is a new method to create the box plot. f comma x1 comma x2 दो ही आउटपुट है ना. So f क्या है? f is a figure. So we'll define figure for that. plt dot subplots 1 comma 2 comma fixed size is equal to 25 comma 8. And तो देखो यहाँ पे x1 क्या है, मतलब 1 रो 2 कॉलम शुड बी देयर. x1 x2 रहेगा वो, और f इज अ फिगर, सो ये है फिगर साइज. दिस इज व्हाट वी आर डिफाइनिंग ओवर हियर. सो फर्स्ट प्लॉट क्या रहेगा? बॉक्स प्लॉट रहेगा लेफ्ट साइड में. किसके लिए? माई डी एफ ऑफ कॉलम. जो कॉलम अपन पास करेंगे उसके लिए रहेगा. एक्सिस विल बी x is equal to x1. Then we have x1 dot set underscore title column comma box plot. तो ये कॉलम का नाम है. And x1 dot set underscore x label is box plot. x2 dot set underscore y label is values. And now we are replacing outliers. So my df underscore out is equal to replace outlier my df comma call. And then we are plotting box plot after outlier treatment. So SNS dot box plot my df underscore out of column x is equal to x2. x2 dot set underscore title column plus box plot. सेम रहेगा ये, सिर्फ इसमें my df underscore out यूज कर रही है, जिसमें रिप्लेस आउटलायर फंक्शन जो अपन ने बनाया था वो फंक्शन यहाँ पे यूज कर रहे हैं. दैट्स ऑल. सो x2 dot set underscore x label box plot, ये लेबल है, x axis label, and x2 dot set underscore y label y axis का लेबल है value. And last but not the least, we'll write on plt dot show. And how to call this function. ये function का नाम है. इसमें argument क्या है? First my df, which is nothing but your data frame, and last is column name. So title column plus चाहिए, plus dictionary of data equals element 0 and 1. Yeah. Say title y level. This is fine now, right? So if you see, देखो BMI के लिए पहले आउटलायर थे, अभी नहीं है, right? Similarly, if you plot for charges in INR, you can see that we have outliers over here, we don't have outliers over here. Is it clear for everyone, this function? So this is what we have for the outlier detection plots. Now, just a minute. If we have a mini project, I'll just check that for pandas library. So this is our data and test. I'm just downloading this and I'll just share my screen. Yes. New folder, data analysis using pandas. Let's write down this. And so ये project है, इसके लिए we will require the notebook first of all. Sorry, data. Is it zip? Okay, need to unzip this. Let's take this and let us paste it over here. Right. Upload strain.csv and upload this. Let us create a new notebook. Now we need panda. Now let us import the necessary libraries. Give heading as importing the necessary libraries. Import pandas as pd. Import numpy as np. df is equal to pd dot read underscore file का नाम train dot csv, and if you just write down, it's not there, read underscore csv, and then df dot head. Right, so ये है आपका data. Now let us go with the EDA, which we already have done, discussed. df dot shape, df dot describe, df dot info. Now what is the shape of the data? It is 5,50,000 rows है यहाँ पे देखो. It's quite big data. And if you just check df dot is null dot sum, so we have 17,000, 1,73,638 product category 2 and 3,83,247 product category 3. So how to remove this null values, how to handle this null value? So let us add heading as handling missing values. And what are the different ways that we have to handle missing values? First way is to drop missing values with drop na method. Second, fill missing values with zeros. You have third, fill missing values with the test statistics. And you have fourth, fill missing values backward or forward. Right, so let us go with df is equal to df dot fill na method is equal to bad. Now if you check df dot is null dot sum, you don't have any null values. You have only one null values in the product category. So let us check the let's check product category 1 and product category 2. Sorry, 1 के लिए तो नहीं है. Product category 2 and product category 3. इसका अगर आप हेड चेक करोगे, लेट्स सी वेयर वी हैव नल वैल्यू, तो रो नंबर 0 में ही नल वैल्यूज है, तो वी कैन ड्रॉप दैट. और लेट्स से df is equal to df dot fill na, method is equal to backfill. You can write down this, and df dot is null dot sum, you can use this. So we don't have the null values over here. Now we have indexing and slicing. In pandas. So in this thing we have discussed two functions, right? First is LOC, second is ILOC, and third you have is IX that we have not discussed. LOC क्या करता है? Label based करता है. मतलब you have to give label, let's say column name in that. ILOC is just integer based. You cannot give column names. And you have IX. What it does is it does the slicing based on the both label and integer. So what we'll do is we'll write down df1 is equal to df dot copy, open and close this bracket, df1 dot loc of 0. So this is your first row of the data, right? So I'll just write down what we have done over here, selecting the first row of data frame. Then what do you have? Let's select first 5 rows for a specific column. So df1 dot loc comma purchase column dot head. तो ये परचेस कॉलम के लिए फर्स्ट 5 rows we are selecting, right? Now selecting first row of a data frame by using ILOC. df1 dot ILOC of 0. Select last row of data frame. How we can do is last row कैसे करोगे आप? By using negative indexing, obviously, right? Then what do we have is We have indexing of maximum and minimum values. तो अगर आपको ये जो परचेस कॉलम है, परचेस कॉलम, इसके लिए आपको मैक्सिमम फाइंड करना है, तो IDX मैक्स कर सकते हो. परचेस कॉलम में मैक्सिमम वैल्यू क्या है, ये. Similarly, you want to find minimum, you can do it by writing down IDX minimum, right? तो ये क्या है, दिस इज आई थिंक इंडेक्स diff of head, that's it, 87480, नहीं तो 440 है ना, 442 लिखते हैं. तो हेड के लिए 87440, ये रो के लिए सबसे मैक्सिमम परचेस वैल्यू रहेगा. परचेस परचेस क्या है, 23,961, ये परचेस है. तो ये मैक्सिमम कौन से रो के लिए वो मिल रहा है आपको, सिर्फ 87440. और मिनिमम 5,45,946 रोज के लिए मिनिमम वैल्यू. नाउ व्हाट वी वांट टू डू इज वी वांट टू गेट द रो with the maximum purchase value. So df1.loc, df1 of purchase dot idx max open and close bracket. तो देखो ये परचेस के लिए मैक्सिमम वैल्यू का कौन सी है, वो अपने को मिल रही है वहां पे, राइट. And this is what we can do. Then what we can do is, तो इंडेक्सिंग है, we have let us see the indexing and re-indexing in pandas. Let's see this indexing and re-indexing in pandas. So let's create a data frame. Let's create a data frame. Let's add food is equal to this data frame, pd dot data frame. इसमें place home, home, then write down hotel and hotel. Time, lunch, dinner, lunch and dinner, right? Right after this, you can write down food, soup, comma, rice, comma, soup, comma, chapati, comma, price in dollars. Rather than 10, comma, 20, comma, 30, comma, 40. And then check what is in food. So this is your food, right? Now set an index for this. Set an index. How to set index? Let's see this. Food underscore indexed one. ये क्या कर रहे हैं, डेटा फ्रेम, एक स्पेशल डेटा फ्रेम बना रहे जिसमें इंडेक्स मुझे चाहिए. आई वांट टू सेट इट एज, सेट इंडेक्स एज किसको, प्लेस कॉलम के लिए, प्लेस. एंड देन इफ यू चेक व्हाट इज देयर इन दिस, तो ये जो प्लेस है उसके अकॉर्डिंग आपको इंडेक्स सेट हो रहा है. देखो मतलब द सिंपल थिंग इज, ये जो 0 1 2 3 है उसको अपन हटा रहे, इंडेक्स प्लेस से स्टार्ट कर रहे हैं, दैट्स ऑल. अगर आपको प्लेस एंड टाइम से इंडेक्स चाहिए तो यू कैन डू दिस ऑब्वियसली. लेट्स से प्लेस इंडेक्स 2. यहाँ पे दो कॉलम है ना, तो यू हैव टू क्रिएट अ लिस्ट, प्लेस एंड टाइम, देन यू कैन डू दिस. तो देखो प्लेस एंड टाइम दोनों इंडेक्स है, होम, लंच, डिनर, ऐसा. Now you want to reset the index. जो index set किया है, you want to reset this. What you can do? Suppose food index 2 जो है, इसके index reset करने हैं आपको. You take this out. You will write down just one thing. Food index 2 dot reset underscore index. Open and close bracket. And if you run this, you will be able to get this. So likewise we have then sorting. How you can do is sorting. Let's create the heading as sorting in pandas. So pandas provides two kinds of sorting. First is sorting by label. Second is sorting by actual value. So let us write down first point as sorting by label. Now what we'll do is we'll just write down this. We can use the sort underscore index method to sort the object by labels. Data frame can be sorted by passing the axis arguments and the order of sorting. So df2 dot sort underscore index. We are sorting the, तो df2 नहीं है क्या, df1 है, sorry, df1 जो कॉपी किया था. We are sorting this on the basis of index. So देखो 1001, रो लेबल्स, रो असेंडिंग फैशन में किया है. मतलब if you just see what is there in df dot head, this is it sorted, is it sorted or not? Let's check this. Now we can sort it by some specific column. Let's say df1 dot sort underscore values. We want to sort by, let's say, product category 1. So product category 1 कहाँ पे है वो will take. Let's say product category 1 से आपको sort करना है. So I'll just write down this and I'll check. तो product category 1 जो है उससे sort हुआ है अब यहाँ पे, मतलब ascending इसमें 1 1 फिर 20 like this, right? So you can sort by specific columns out there. Now we have categorical data which we have discussed, right? Categorical data क्या होता है? जो strings होते हैं, right? Categorical data in Panda. So what we can do is we can check the data types of variables in the dataset with the following commands. So how we can do this in df3 is equal to df.copy. Let's create a copy of this data frame and let us write down df3 dot d types. Now gender जो column है gender, उसके लिए अपन describe function use करेंगे. So df3 of gender dot describe. Similarly age column है वो भी object है, मतलब it is your categorical data, right? Age column is your categorical data, gender is your categorical data. So again we can describe the age column. कौन सा column और categorical है? City category, right? This is also not number. So city category, I'll just copy this and I'm going to paste it over here. Sorry, not here. df3 here. City category dot describe. Now gender जो column है df3 में, gender column उसमें unique values कौन से? Unique values. So female and male are the unique values in your gender column. Similarly df3 age column, unique values कौन से है? Age column में ये unique values है. Now how you can rename the categories, how you can append new categories, how you can remove the categories, we'll see this. So df3 of gender dot value underscore counts, open and close bracket. These are your value counts, and df3 city underscore category dot value underscore counts. Can use this. And then df3 gender column value underscore counts ascending is equal to true. So we can sort this value counts in the ascending fashion. मतलब जो column के less numbers है वो it will come in the beginning. Similarly यहाँ पे भी आप ascending is equal to true लिखोगे तो जो कम है सबसे वो पहले आएगा. Now we'll go with the basic functionalities in pandas, मतलब जो basic functions है, which we have not discussed. Access function है, D type है, this we already have discussed. Empty है, so access क्या करता है? It returns a list of the row access labels. D type क्या करता है? It returns the D type of the object. Empty क्या करता है? It returns true if series is empty. And we have in dimension, NDIM. What it does is it returns the number of dimensions of the underlying data. By definition 1. We'll see this everything. I'm just writing down the description for this. Returns the number of elements in the underlying data. And we have values. What values will do? It will return the series as ND array. And we have head. What does this head will do is it will return the first 10 rows. We have tell. What this tell will do is it will return the last 10 rows. राइट, तो ये हो गया आपके सीरीज के लिए. ये किसके लिए है? दिस इज फॉर सीरीज. Series basic functionality. Similarly, we have data frame basic functionality. So we have T is equal to transpose rows and columns. Access is equal to, it will return a list with row access labels and column access labels and only members. We have D types, which will return the D types in this object. And we have empty, which is true if ND frame is entirely empty. No items, if any, of the axis are of length 0. N dimensions is equal to number of this array dimension. Is it fine? This is what we have. I mean, इसके बाद में भी बहुत सारे functions हैं जो कि अपन discuss करेंगे in the next session. We have shape, we have size, we have values, we have head function, and we have tail function. We'll see this in tomorrow's session. So as of now, I'll not give this notebook to you, or if you want, chalo, I'll just give this. Not an issue. So what we have discussed outlier detection, and we are going to discuss the mini project in on pandas, right? So let's write down pandas. And let us quickly take the notebooks. Hmm. Python data analysis pandas. Right. So this is what we have. We'll stop here for the day. If you have any questions, you can ask. All right, then I consider nobody have any doubts. We'll stop here for the day. Tomorrow we'll continue with the same project. So thank you and happy learning. Bye.